This is Faith. This is just a quick video showing how I work through the long division of polynomials. So I just wanted to start with a quick example of long division in just numbers. So when we divide, we say how many groups of 4 are in 1, and there's not any groups of 4 in 1 because 1's smaller than 4. Then we would say how many groups of 4 are in 15. And there's 3. 3 times 4 is 12. We subtract and we get 3 and bring down your 9. Then we would say how many groups of 4 in 39. There's 9. 4 times 9 is 36. Subtract and we're left with 3. Now once you get it higher in math, you're taught to add a decimal point, add a 0, bring the 0 down, keep dividing. But that's not really what we want to do here because long division of polynomials deals with remainders. When we're first taught, we would say this is 39 remainder 3. That's not really what we want either. We want this in a fractional format. So we would say this is 39. And then rather than saying remainders 3, we would say 3 over 4. We're keeping our original 4 that we are dividing by and using it again as the divisor for our 3. And that's the same process of how we're going to deal with the remainder and the long division of polynomials example. So we have 2x plus 1 is what we're dividing by. Now, we want to pay attention because we see we have an x to the third and just an x. There's no x squared, but we do need to include it. Now, because the x squared is gone away, we know that it's been multiplied by 0. So I'm going to put a 0x squared in here as just a representation and a placeholder. Because otherwise it would be like if we were dividing 109 by 4, so we had a 0 here, and leaving that 0 out, just getting rid of our tens place, that wouldn't really work. So when we're dividing, we're just going to look at our first term here and use it to guide us along the way. So I want to say how many times will 2 go into 8? Well, that's 4. And how many times do I need to multiply x to get to 3x? And that's 2 more. I have 1x, I need a total of 3. So I'm going to start by multiplying by 4x squared. So 4x squared times 2x gives us 8x to the third. And 4x squared times 1 gives us 4x squared. Now, what I like to do is because we're subtracting, and I personally tend to lose my negatives and subtractions, I like to put this in parentheses and my subtraction on the outside. And then I think about what that means. Well, subtracting is the same as adding the opposite. So I'm going to turn this into adding the opposite of each number. And now I've kept track. That helps me keep track. So I'm going to cancel these out. Well, 0x squared plus a negative 4x squared is a negative 4x squared. And now I'm going to bring down my 14x. Okay, now I look at this negative 4x squared. Well, to multiply 2 by something to get a negative 4x, that's going to be a negative 2. And to get x to an x squared, I'm going to multiply by x. So negative 2x times 2x is negative 4x squared, and negative 2x times plus 1 is a negative 2x. Again, we're subtracting. I'm going to change it into adding the opposite, so those both become positive versions of themselves. These cancel, and I'm left with a 16x. And finally, bringing down my plus 9. Okay, well, what do I need to multiply a 2x by to get a 16x? I need to multiply it by 8. 8 times 2 is 16x, and 8 times 1 is 8, so plus 8. Again, subtracting, so I'm going to change it to adding the opposite. So my 16x is canceled, and I'm left with 1. Now, I can't divide anymore. This 1 doesn't have an x, so that means this is my remainder. ER. Now, just like I did with my numbers, and I left it as 3 over 4, that's what I'm going to do here. I'm going to say 1 over 2x plus 1, what I divided by. Now, because this is positive, I'm going to put addition, and so my final answer to 8x cubed plus 14x plus 9 divided by x squared plus 1 is 4x squared minus 2x plus 8 plus 1 over x plus 1. So a slightly more complicated looking polynomial. So I hope this has helped you out, and